All right, you guys, let's take a look at the concept of similarity. First off, similarity, a lot of people understand that we're kind of talking about some stuff that is the same shape, but we're looking at a different size. So we're looking at some object that's been dilated either from big to small or small to big. Now that's a very layman's term type of definition. We got to get a little bit more accurate. The definition's really stating is that all these polygons are made up of really two kinds of items, sides and angles. All right. For objects to be similar, the corresponding angles must be congruent. Now that doesn't mean all of the angles in these shapes have to be the same, but like this bottom left angle better be the same measure as that bottom left angle. Otherwise, we're going to be unable to keep the same shape. This top angle, whatever it measures, it's got to be equal to the matching or corresponding angle. This angle on the right better equal the same angle over here. And if there's a fourth angle, those corresponding pieces have to be the same. This is in order to keep the same shape. Now, the sides are certainly not going to be the same because we end up with a different sized shape. All right, but there is a relationship. The corresponding sides must be what's called proportional. That's what we studied last time. You have some exposure to this in your previous math courses as well. What that means, if we're talking about proportional, if you remember, we can make a ratio of matching sides. Like this side measures 4, and its corresponding side measures 6. If I make a ratio, in order to be proportional, this ratio has to be the same as all the other ratios that we set up. So let's make them all. If we have 6 compared to 9, we have 2 compared to 3, and then we have 8 compared to 12. The question is, how do we verify? All right, you need to verify and investigate whether these are all the same. All right. One way to do that, we've talked about, you can cross multiply and go all the way through. Or you can reduce all of these fractions. Well, 4/6 reduces to 2/3. 6/9 reduces to 2/3. 2/3 is a fully reduced fraction. And if we divide a 4 out of each of those, it turns out all of those ratios reduce down to the same fully reduced fraction. This fraction here is referred to as the similarity ratio. Similarity ratio for this problem is 2/3. This is a common relationship amongst all the corresponding sides. All right. And if I did know that all the corresponding angles were equal, and I verified that the sides were proportional, then, and only then, can I write what's called a similarity statement. Similarity statement would be me naming one of the shapes. Let's say I had one of the shapes A, B, C, D. So I just chose to start at A, and I start naming it around in a circular fashion. Well, the way that I name the other shape and the symbol for similarity is a single squiggly. All right. Well, it's important that the way I name the other shape, that all the matching pieces match up. A matches up with F, so I should start with F. All right. B matches or corresponds to G. Then I need to go to H, then I. All right, so these shapes, very important. Similarity ratio is an important concept. This is what's going to allow us to find missing sides. This could also sometimes be referred to as the scale, as you're talking about architectural drawings or blueprints. All right, this is a 2 to 3 scale. All right, and the similarity statement sometimes helps me identify and make sure I understand which pieces correspond so that I can set my problem up correctly. All right, all very, very important basics here. Now, we take this into a pretty confusing situation. So I'm kind of going straight to a difficult problem here. The good news is I don't have to investigate similarity. I've already been given the similarity statement, so I know which pieces match up. Now that I know they're similar, if I'm missing some sides, I could set up some proportions to try and solve the missing sides. I'm just going to tell you the reason I'm covering this. Hopefully you see that there are two triangles. It's a triangle here, this small one here, and there's a larger one that overlaps it. All right. There's a lot of people going to set up these proportions incorrectly. All right. Because you got to be careful. In my opinion, the best way to do this is kind of make a little side sort of scratch problem. There's a small triangle, and I know there's a bigger triangle that's overlapping. So if I split them up and I recopy the sides, I know this side was 24. Y, and the bottom is X. That's not the difficult problem. The problem is, what's this side on the big triangle? Well, it's not 4. 4 would just be from here to here. I need to put 4 and 24 together to know really the measure of this side. 24 plus 4 is 28. This side is going to be Y and 5 put together. So Y plus 5. And then I know the bottom, that part's a little bit easier. That was just 30. So it's important if I want to set up a good proportion, all right, I need to make sure and use the matching sides. Now, the other thing, I don't want to make a proportion that has two variables involved, because if I only have one proportion and two variables, I can't solve for either. So the two sides that I do have, 24 and 28, I certainly want to involve those. Now, if I want to solve for x, then x matches up with 30. And the best way to attack this problem is to cross multiply. All right, 28 times x, 28x. Remember, we are making a new flat algebra problem, not another ratio. 24 times 30 happens to be 720. I want to finish this off. I want to divide both sides by 28. So if I do 720 divided by 28, man, look at that crazy fraction. But remember, if you're working with one of these TI 83, 84 pluses, use this math button, all right? If I hit math, if I select fraction, then it'll take my answer and convert it into a fraction. There's the fully reduced fraction. Now, you may be asked to round, which would be totally fine. If I was rounded to tenths, I could put 25.7, but it's rounded just to approximate value. 180 over 7 is a hyper accurate answer, which is always the best way to go if you have that choice. All right. So the other proportion that we could have set up, if I want to solve for y, all right, again, I want to use that 24 over 28, and then I'm going to have to use the y over y plus 5, because that's y matches up with y plus 5. And now here we go at it again. 28 times y is 28y. We have to be careful here. One item times two items. We do that all the time. It's called distribution. 24 times y is 24y. 24 times 5 is 120. And now I can go about solving this problem. Move all the y's to one side. I actually have 4y equals 120. Divide both sides by 4, and turns out y is 30. So once you kind of get the knack of these overlapping triangles, it's really not that bad of a problem. But in my opinion, I think the best way to go about this is go ahead and just take the time to make a little scratch situation. Separate those triangles so really the proportion is slapping you in the face. All right? Good luck, you guys.